Hello and welcome to day 2 of Unit 5 Quadratics. Today we're going to be looking at solving for equations that have x squared in them, along with hopefully putting them into vertex form and finding the vertex and finding the y-intercept. So first we're going to look at something that is this. If I said solve for x here, what's the first thing you need to do? Well, you need to move the b over. So ax squared equals c minus b. You have an added b, we subtract b. X squared is not alone yet, so we need to divide by a. We're going to get x squared to equal c minus b over a. And then we have it squared, and so we have to get rid of the squared. The way we do that, we square root it because they are inverse functions of each other. And the result would be x equals, because we square rooted, we need to always put a plus or minus in front. Let me show you why we have to put the plus or minus. So I'm going to be right up here. If I said x squared equals 4, you would tell me 2. 2 squared does equal 4, but what else equals 4? Negative 2 squared equals 4. So whenever you square root something, you always need the plus or minus due to this fact right here. The fact that the positive 2 squared, negative 2 squared does equal the same thing for us, so you always need a plus or minus. This can be really key when solving for quadratics. You always need the plus or minus. This is going to come into play when we have finding x-intercepts. So real quick, pause the video and look at example 1 and 2, and then try example 3 based on examples 1 and 2. So pause it, read examples 1 and 2, follow it along, and then I will come back with the answer to example 3. Please pause. I didn't finish it here, but look at what I did. One thing that I want to state before I go on is when you have the plus or minus, this number or variable or whatever we're doing when we add it over, subtract it over, goes in front of the plus or minus. So to write in correct mathematical notation, x equals 2, because we're adding 2 here, plus or minus 4. Now, if it was in square root form, as in right here, we would be done. But because these are nice numbers, I write it out just so we don't have any confusion. 2 plus 4, 2 minus 4. And then our final answer would be x equals negative 2, x equals 6. And both would be our answers. These are solving for the x-intercepts. That's what this is doing. When you have an equation set equal to 0, you're solving for x-intercepts. So that's what you just did there. That's solving quadratics. If you have any questions, please make sure you come see me before class. So what we're going to do here is we're going to not do the first one. You guys are going to complete this one. Please complete before class. So that's going to be part of your homework. Please complete that before class. I'm going to start right here. Now, we're finding standard form. This is called expanded. Okay, you're just expanding it. The vertex, you do 2 things to find the vertex. 1, you find the x value. Then 2, you plug in x to find y. This is a point. Your final answer is a point, x comma y, and I'll show you that. The x-intercepts, to find the x-intercepts, you set equal to 0. To find the y-intercept, you plug in 0 for x. When we go back to x-intercepts, when you set it equal to 0, what that's meaning is you're making y equal to 0. So you're plugging in 0 for y. Same thing for y-intercepts, just opposite, you're plugging in 0 for x. So that's how you find both of those. Again, you're doing this question before class. So let's go here. The second problem, x plus 3 squared minus 1. So we're going to expand it. You can rewrite this out as x plus 3 and x plus 3. So you get x squared plus 3x plus 3x plus 9, and then minus 1. Minus 1 you can't forget about. So you're going to get y equals x squared 3x and 3x is 6x, plus 1 minus 1, plus 8. There's our standard form. So you saw how I did that. Now, to find our vertex, I have to do this x equals negative b over 2a. Our a here is 1, our b here is 6, and our c is 8. And so if we're going to do x equals negative b, negative 6, over 2 times 1, because the a is 1 here. So we're going to get x equals negative 3. I'm now plugging, this is our x value of the vertex. The vertex is the highest or lowest point in a quadratic. So when I plug in negative 3 into this problem, y equals negative 3 plus 3 squared minus 1. You'll notice that this goes to 0. 0 squared is 0 minus 1. You're going to get y to equal negative 1. And therefore your point is now negative 3, negative 1. Here's the x value, here's the y value. There's our vertex. This now just told us that this is a minimum. How do we know it's a minimum? Well, our coefficient is positive here, so I know our end behavior goes up, and I'm just going to connect it. That would be our minimum, negative 3, negative 1. So I've gone to standard form. I found the vertex using this x equals negative b over 2a to find the x value. Plug that into our equation to get the y value. I just found the minimum point here. We're now going to find the x-intercepts. So the x-intercepts, I take y, plug in 0 for y. And this looks exactly like what you just worked on the other page. So I'm going to add the 1 over. I'm going to now square root both sides. Because I've square rooted it, I need a plus or minus. The square root of 1 is 1, so I'm going to get plus or minus 1 equals x plus 3. I'm going to subtract the 3 over and get x to equal negative 3 plus or minus 1. Because these are nice numbers, I now write it as negative 3 minus 1 is negative 4, and negative 3 plus 1 is negative 2. There are our two x-intercepts. You'll notice here that the x-intercepts, so if I did this, this is negative 3, negative 4, negative 2, that the vertex must be right in the center of those due to symmetry. Our last part is the y-intercept. The y-intercept is when you plug in 0 for x. Notice here I'm going to use the standard form. 0 squared plus 6 times 0 gives you 0, plus 8 gives us 8. And you guys know this from the polynomials unit that this portion right there will always give you the y-intercept. So there's one example completely done for you. If you need to pause it, rewind it. If you have questions, let me know. I'm going to move quicker on the next two problems. Next problem, 2y equals 2 parentheses x plus 3, x plus 3. Well, I already know that. That's the same thing we did above. It's x squared plus 6x plus 9. I have to distribute the 2 to both, or to all three terms. When I do that, I just distribute it to all three terms. I have to add the 1, so I get my final answer, 2x squared plus 12x plus 19. I now find the vertex. Remember that our a value is 2, b value is 12, c value is 19. So x equals negative b, negative 12 over 2 times 2. 2 times 2 is 4, so negative 12 over 4 is x equals negative 3. Notice that when you plug in negative 3, you get 0, so this entire part of the equation cancels, doesn't cancel, it becomes 0. 0 plus 1 is 1, so y equals 1. And I now know my vertex is negative 3, comma 1. To find our x-intercepts, we go 0 equals 2 parentheses x plus 3 squared plus 1. I'm going to subtract the 1 over and divide by 2. I'm going to do 2 steps in 1 there just because I can. So negative 1/2 equals x plus 3 squared. and then I'm going to square root both sides. Square root of -1/2, I'll just put the plus or minus there to begin with, equals x plus 3. I don't even need the parentheses there. Notice that I get x to equal -3 plus or minus the square root of -1/2. What do we know about square roots or radicals? To the power of even radical can't have negatives, and so therefore you would write down no x-intercepts. There are no x-intercepts. We're going to get into this later on, but they're going to be called imaginary roots. So this is imaginary because we have a negative square root, and therefore there are no x-intercepts. Final part for y-intercept, you look at the c value, y equals 19. Okay, probably should have written this as a point, but that's how you would do it. And the last one that I'm going to look at with you is number 3, is this one. Sorry, the fourth one was this one. You guys are going to complete this also. So here, notice that we have x plus 2. X plus 2. We get x squared, -3. Y equals -3, parentheses. X squared, 2x and 2x gives you 4x. 2 times 2 is 4, plus 4. This -3 must be distributed to those. So y equals -3x squared minus 12x minus 12 plus 4. And we finish off with -3x squared minus 12x minus 8. Combined those terms. Our vertex, x equals -b. The -b would be positive 12 in this case, over 2 times a. a is -3. 12 divided by -6, x equals -2. Notice that you know you did it correctly because when I plug in -2 here, once again, this part of the equation goes to 0. 0 plus 4, y equals 4. So my vertex is -2, 4. X-intercepts, we set equal to 0. -3 plus 2 squared plus 4. I'm going to subtract 4. -4 equals -3, x plus 2 squared. Divide by -3. And notice here, when you have two negatives, you're going to get positive. And I will square root that. Again, square root this. And therefore, I'm going to get x to equal -2 plus or minus the square root of 4 over 3. I did skip some steps there. Pause it if you need to go and just do it on your own. I can also rewrite this as x equals -2 plus or minus 2 over square root of 3. The reason being that square root of 4 is 2. So I could also write it as this. And the y-intercept is -8, which probably should be written as a point. 0, -8. So there are two x-intercepts here. Not nice though, so we can leave it in radical form. We have our y-intercept, our vertex, and our standard form. So to recap, you guys are going to complete the first one. You guys are going to complete the last one. And I'd like you guys to answer number 2 here. And then, yes, I'm giving you guys some extra work. I would like you to write each of number 4 in standard form. I don't want you to do anything else, but I want you to write them in standard form. It's going to save us time in class. So for all of 4, you're writing in standard form, the same thing we did in the first column above. So you're going to complete the first one and the last one, and write all of number 4 in standard form, and finish number 2 up. I will see you in class.